regular timing using a regular timing light. And then I'm going to show you how to use a digital timing light. When you're adjusting these arrows, this is not adjusting the timing. This is the timing that counts for performance, okay?
Basically, you just need to go as high as you need to go till that line stops.
My name is Jonny Mopar, and in this video, I'm gonna show you how to use a regular timing light versus a digital timing light, and I'm gonna give you a basic understanding of timing, both base timing, total timing, and vacuum advance. So there's basically three parts to timing. There's initial timing, also known as base timing, also known as idle timing. That's what the factory used to measure everything. The next is total timing, and then the third part of timing is vacuum advance timing. So for right now, let's put total timing aside and let's put vacuum advance aside. And I'm just gonna show you regular timing using a regular timing light. And then I'm gonna show you how to use a digital timing light measuring the same thing, base timing. Okay, regular timing light is hooked up to the battery, positive, negative, and then we are clamped on the number one cylinder spark plug wire. And this is a big block, so the rotor turns counterclockwise. To advance your timing, you would turn the distributor this direction, which is clockwise, opposite of the rotor. You're basically getting that spark plug wire to the rotor sooner to get a sooner spark. And to retard it, you're gonna go counterclockwise. And I'm gonna use the big 0440 to kind of illustrate what's going on. Again, we're just looking at base timing. We're looking at this line on the harmonic balancer. That line to this 0 on the timing chain cover indicates top dead center on cylinder number 1. And I wanted to show you this timing chain cover. This is the same timing chain cover that's on the 440 in the wagon. So you get an idea of where, when the light is flashing, because it's hard to see. Basically, that's 10 degrees advanced. That's top dead center, which is 0. And then here you've got 20 degrees advanced.
All right, so we're seeing 20 degrees because I have the vacuum advance hooked up. Forgot to disconnect it. So I'm disconnecting it right now. See how the RPMs drop? So now there's my base timing, which is idle. Or you could call it initial timing. You can see that the timing mark is right at 10 degrees.
So when you're measuring timing, I like to look at it as a triangle or pyramid. There's 3 corners. So there's 3 ways you can view timing, which is how we just checked initial, is using the timing chain cover to indicate what timing is. So that's where the numbers are. That's where we're gonna measure timing. Our balancer is a single line at the 0 degrees to top dead center. So it is a fixed point and we are unable to use it for measuring in this configuration. I'll get to how we can use the harmonic balancer here in a minute. The third is the timing light. Right now, this timing light is a fixed measurement. This light is gonna flash when the rotor gets to the number 1 plug wire. It is fixed to when that spark occurs, all right? So, but the thing is you can change how you're viewing timing between those 3 corners. You can do that with timing tape. So if I put timing tape on the harmonic balancer, I would now have a bunch of different scribe lines on here. Or I can get a harmonic balancer in aftermarket that already has the scribe lines placed on here with the different degrees. So if I'm gonna use a balancer that's got the scribe lines on it, I have to disregard the lines that are on the timing chain cover except for 0. Remember, of the pyramid, of the 3 corners, 2 of them have to always be fixed to use the third to measure timing. Okay, so this is what we would see on the engine if it had this balancer right now. As I'm running, if I'm using a regular timing light, I wouldn't use all these lines. I would go off of 0 on the balancer, and then I would use the line on the timing chain cover to measure timing, which would be 10 degrees. Now you gotta flip your brain here for a second. The other way to measure it is to disregard these lines and only use the 0 line on the timing chain cover, and then use the lines that are scribed on your harmonic balancer, or if you had timing tape on it, and you would see that there's 0 degrees, there's 10 degrees. So like in this example, you can see very clearly side by side that this is the same thing. This is 10 degrees whether you're looking at 0 here and 10 here, or you're looking at 0 here and 10 here. It's 10 degrees, same thing. Doing that, having a harmonic balancer with scribe lines gives you more flexibility, because mainly when you're measuring total timing, because if we were to measure total timing, which requires bringing the RPM up, this timing mark is going to change to, let's say 32 degrees. Let's just say there. Now you can see I can't use the timing chain cover because there's no more scribe lines that go down this far. So I won't be able to measure 32 degrees on the timing chain cover. So the only option is to use the harmonic balancer that has these scribe lines or timing tape, and now I can measure 32 degrees from here against the 0 on the timing chain cover. Okay, but there is a third way, and that's using a digital timing light. Okay, so again, depending on which way you're measuring it, you have to use a fixed value. You have to use 0 on these two to be able to use the third corner as your way to measure. Let's go back to initial timing. Let's say the engine's running at 10 degrees. Whether I measure it here or I'm measuring it here, it's 10 degrees. And I put a digital timing light on it. When I first hook it up, it's going to read 0 on the screen. That is using that timing light basically in its natural configuration. The light is just firing when the spark plug wire is firing. But there are arrows on the timing light you're going to adjust. All right, same thing, easy to hook up. Number 1 plug wire, negative to negative, positive to positive. The engine's not running, so we don't see any RPM here. I'm going to leave it off for a second because it's hard to hear me with the engine running. And then here's your timing. So when I first start this thing up, this is going to indicate 0. My harmonic balancer line is going to be 10 degrees advanced against the timing chain cover. Then what I'm going to do is I'm going to adjust these arrows, and I'm going to align the harmonic balancer and the timing chain cover. I'm basically going to hit that arrow on the timing light, and I'm going to align the 2 zeros from the harmonic balancer to the timing chain cover. In this particular case, I would be bringing this line to 0 here. When I do that, the number on the screen of the digital timing light is going to change. So again, we got the triangle. You've got the balancer, the timing chain cover, and the timing light. So in this scenario, we're going to use the timing light to measure. So the other two need to remain fixed at 0 in order to see timing. So whatever we see on the screen, once we align these 2 zeros, that's our timing. And before I start it, just to reiterate, I disconnected the vacuum advance because we don't want that factoring in.
Okay, so what I'm going to do, I'm basically watching the harmonic. When you first start, this is basically like a normal timing light. Now the 0 mark is up there towards the right. So what I'm going to do is I'm going to adjust these arrows. Zero. See the line moving? Timing did not change. You can hear the engine, it didn't change. All we did was move from checking our timing at the timing chain cover to checking it at the timing light. That's the only thing that's occurring here when you're adjusting these arrows. The number here is our timing, which is 10 degrees at idle, or base timing, or initial timing, whichever you want to refer to it as.
So as you can see, that's pretty basic, pretty easy using a digital timing light. Now, one thing I want to really point out, because this might seem basic and obvious to a lot of people, but if you're just doing this for the first time, you're just getting into muscle cars and stuff like that, or classic cars, you may not know this. When you're adjusting these arrows, this is not adjusting the timing, okay? You might think, oh, well, I'm adjusting these arrows, I just changed the timing to 10 degrees. No, The timing on the engine is 10 degrees. What you're doing when you're moving these arrows and bringing those zero lines to align to each other is you are basically transferring how to measure timing from the timing chain cover to the digital timing light. That's all you're doing. You're moving the measurement from there to here. That's it. To actually change the timing, we need to loosen the distributor and we need to rotate it. If we're going to go more advanced, we turn counterclockwise. And if we wanted to go, if we want to go more advanced, we would turn clockwise. And if you wanted to retard it, you would go counterclockwise. Okay, so that was base timing. Now what about total timing? What is total timing? There are weights inside the distributor down below. And when the engine is running in centrifugal force, as you rev up the engine, the centrifugal force is going to pull those weights open. There's springs holding them in the closed position. So as the engine revs up and those weights move, what you're going to see is this rotor is going to rotate. Okay, so as the RPMs come up, it rotates in this direction, which basically is moving when you're going to see spark. It's going to bring, because this is turning counterclockwise and you're moving this direction, you're going to get more advance. Okay, total timing is basically where the engine is running at, you know, wide open throttle. You want maximum, there's maximum load, maximum horsepower, you're jumping on it, you're going to pass somebody, or you're at a drag strip and you got it full throttle. This is the timing that the engine is going to run at. This is going to be your maximum horsepower timing. This is the timing that counts for performance, okay? Again, three aspects: base timing or initial or idle, total timing, and vacuum advance. So we're going to keep vacuum advance to the side for now. And now let's get into total timing. All right, we know this engine is timed at base timing at 10 degrees. So in order to see total timing, I need to bring the RPMs up so that the weights spread open in the distributor, and then the timing is going to change. So that line that's at 10 degrees right now is going to move off the scale. I can't use a regular timing light to measure total timing unless I have an aftermarket harmonic balancer or timing tape, which I don't have here. So that's what's cool about a digital timing light, is I can measure total timing with a regular harmonic balancer, stock, and timing chain cover. All right, so I'm going to start the engine. I'm going to bring the RPMs up. Now that that line is going to move, I'm going to adjust, again, I'm going to adjust the numbers here, or the arrows here, until the harmonic balancer and the timing chain cover are both at 0. Once they're both at 0, whatever I see here is my total timing.
I don't know if you're able to see the lines because of the frequency of the camera versus the engine, but anyway, or the timing light. Basically, this is flashing at 0 right now because my timing light is set to 10. At some point as I rev it up, the line's going to stop moving, because basically that's when the weights are completely spread open. So you don't have to go to 2,500. Usually people say 2,000 to 2,500 gets you in total. Basically, you just need to go as high as you need to go till that line stops moving. Once it stops moving, then we align the scribe line on the balancer to the 0 mark on the timing chain cover, and whatever we see here is our total timing. You see it's idling around 650 RPM right now. Bring the RPMs up. Okay, it's at 2,000 RPM. I've got the line on the balancer and the timing chain cover aligned to 0. So I have 30 degrees total timing.
So we have 10 degrees base timing or initial timing or at idle, and we have 30 degrees total timing. Now we're going to get into vacuum advance. Let me just show you. This side of the carburetor is ported vacuum. This side of the carburetor is manifold vacuum. There's like a bunch of debate as to which side you should be on when you're running your engine. So for emissions, having your vacuum advance hooked to this side, basically you're going to have the engine running without the vacuum advance operating. And what that does is you're going to be at a more retarded timing, right? With vacuum advance, let's just say vacuum advance adds 10 more degrees. Okay, just for an example. So if I hook up vacuum advance to this side, which is manifold vacuum, it's going to add 10 degrees to my timing. So my initial timing, which is currently 10 degrees, would become 20 degrees. Okay, if I'm hooked up to the emission control ported vacuum, basically that's not being activated, so the engine's going to run at 10 degrees at idle. Okay, the reason is, as I understand it, the running more retarded has the exhaust run hotter, and then that thus burns more hydrocarbons, which makes the engine running cleaner. Okay, so it was basically an emissions control reason. If I run straight off of manifold timing, that 10 degrees is going to get added instantly once the engine starts. Now, the engine's going to want more timing. It's going to run more efficient. It's going to run cooler. It likes timing. Okay, so it's probably better to run off the manifold, but I'm not going to get deep into the weeds and start debating everybody and call everybody else wrong. Okay, this is going to be the actual difference I'm going to show you. So when the engine is idling, you're going to see here that this is going to be basically no vacuum. And then when I open the throttle, just barely open the throttle, you're going to see an increase in vacuum. When I switch it to this side, that increase in vacuum is just going to be there while it's idling. That's really the only difference. And you don't have to crack past idle very much before the vacuum actually activates. So in reality, the only thing that it buys you, because people say, they get their panties in a knot about how it's got to be running on manifold vacuum, it's going to run better, blah, blah, blah. And yeah, there's some truth to all that. But, basically the difference is at idle, you're not going to have the extra timing on this side. And on this side, you will have the extra timing. Okay, that's basically the difference. So I'm just going to show you real quick. Right now we're hooked up to ported, and I'll show you what the vacuum cage says.
Basically, no vacuum. Right there, off idle, that's how much vacuum is kicking in.
Okay, I'm going to start it up again.
You're already fully vacuuming even at idle. Basically, you already got that extra timing, so that's all it's doing.
So for all intents and purposes, I don't think you're going to see much difference in performance or fuel economy based on that. Now, maybe there's a slight advantage in fuel economy because you're getting that extra timing while the engine's just idling, but you're not burning a lot of fuel at idle anyway. So the difference is going to be negligible, basically. So I'm going to go ahead and leave it on manifold vacuum and hook it up to the distributor. Okay, so why do we have three aspects of timing? The first, being initial base timing or at idle, is basically to make it easy, make the engine easy to start. If you ever hear a drag car when they go to start it up and it goes wah, wah, whoom. And then if it's hot, it's like you go to start it and it's like, it's like the engine's seized. Well, it's because they usually run a locked out distributor, so they just have total timing. No vacuum advance, no base timing, just total timing. And being that far advanced, with the RPMs turning so slow, basically when that piston is coming up, the spark is occurring and that flame front is working across the cylinder faster than the piston is coming up because it's not running yet. And so you have that explosion fighting the piston. As the piston's coming up, explosion is occurring, and they're basically both working against each other. Makes it difficult to start. So if you back the timing away when the engine is not running, you're just turning it over very slowly to get it to start. Basically, it's not hard on starters and it's easy to start. Once the engine is running, you don't care about base timing or initial timing anymore because the engine's running. That's the only purpose for base timing. Total timing is getting all our timing in our performance mode, which would be wide open throttle or under a load, like climbing a hill or if you're pulling a trailer or something like that. When that occurs, you know, your initial timing's out the window. You're going to have less manifold vacuum, so the vacuum advance is going to disengage when you're giving it more throttle because you got more air going through it, less vacuum, no more vacuum advance. You're just running off of total timing basically, and that's where your performance is at. Now for vacuum advance, the purpose of vacuum advance is for fuel economy. So when you're just at cruising speed, the engine is just barely running. Let's just say, you know, you're cruising around at let's say 1500 RPM and you're cruising down the road. Well, you're going to have high manifold vacuum at that point. The car's cruising, so there's no load on it. You know, you don't have that load like from an initial stop. You try to accelerate, you got to give it more open throttle. Vacuum drops, vacuum advance disengages. You're getting performance, you're getting power to move the car. Once the car is moving, now you don't need that load isn't there anymore. You're just cruising along. Now you can back the throttle off, your vacuum increases, your pod is going to engage your vacuum advance, and you're going to add more timing to the engine. And what that's going to do is make the engine run more efficiently. Now, if you had that, let's say you had a locked out distributor and you were running total timing at like 40 degrees, as you're cruising down the road, it would be okay. But then when you went wide open throttle, it's going to start pinging on you, and you're going to get pre-detonation, which could damage your engine if you do it too much for too long. So that's why you want the timing to back way to total timing off of advanced or vacuum advanced timing. Okay, hopefully that explains it all to you. All right, so I'm going to go ahead and fire it up, and I'm going to show you what timing is with the vacuum advanced hooked up at idle. And again, you know, we're hooked up to manifold vacuum here, so we'll see a higher number. You know, it was 10 degrees. Now we're going to probably see something over 20 degrees. You know, if a vacuum advance adds 10 degrees or so, we're going to see 20 degrees. And then I'll rev the RPMs up to get total timing, and we'll see what total timing is. I'll have to keep the RPMs like right at the threshold, because you start going too high, you're not going to have vacuum, and your vacuum advance is not going to be engaging. So I'm going to try to keep it around like 1800 or so, maybe 2000 will be okay, and we'll see how much timing we have.
All right, that's at idle. So at idle, I'm getting 27 degrees, 880 RPM. So the RPM went up because the vacuum advance is hooked up now. That increase in timing increased the idle. Again, my harmonic balancer is at 0, my timing chain cover is at 0. Those are fixed positions, and then I'm using the variable position to take a reading from the timing light. So again, 27 degrees at idle. That's about cruising speed going down the highway, around 1700 RPM. So my vacuum advance hooked up adds to the total timing. If you recall, total timing was 30 degrees. Now we're at 47 degrees, so that added 17 degrees to my total timing at cruising speed. If I were to go higher, like let's say under load, wide open throttle, the vacuum is going to drop, and that 17 degrees is going to get removed. It'll back down to 30 degrees under wide open throttle or load conditions.
So before I end this video, let's get into a little troubleshooting, okay? If you're getting erroneous readings, or you're getting a lot of jumping around on your timing mark at idle. Now, if you have a performance cam, and we're not talking extremes here, that's pretty normal, especially with a carbureted engine. You know, it's going to be gasping for air. That's why you get that lope, that anyway, that's going to cause the line to jump around a bit at idle. But if you had like a stock engine and it's doing that, there's a possibility your timing chain is loose. If your timing chain's loose, you got to keep in mind the distributor is tied to the camshaft. The camshaft is tied to the crank via the timing chain cover. If it's loose, basically that chain is tightening and loosening as you're wrapping the throttle, which means the timing is going to be changing and fluctuating while your piston is not. That's running constant. So my son and I got the Winnebago 440 torn down a little more, and the timing chain is a little bit loose, so I could kind of give you an example here of it jumping around. Now, it's not terribly loose, but as you can see, that's how much the camshaft can move around compared to the crankshaft. And that's how much, because your distributor shaft is tied into the camshaft, so it can jump around that much as well. So that could cause, you know, when you're looking at your timing marks, that could cause it to jump around. You know, there's easily, I would say, I don't know, maybe 2, 3, 4 degrees there. It's jumping around. Maybe 2 or 3. But anyway, that could be one of the possible reasons why you're getting a reading that's jumping excessively. So that's a possibility. You might have a loose timing chain. Second possibility, you're getting erroneous readings. Your harmonic balancer has a piece of rubber between this outer ring and the inner ring. You gotta keep in mind, these engines are running around 50 years old, depending on which year block you have. So that rubber gets old, deteriorated, cracked. It might come loose. And if it comes loose, there's nothing holding this ring to the proper position of the crankshaft. So this thing could be floating around, moving on you, or had slipped and moved to a bad location. Now that we got the harmonic balancer off the Winnebago 440, it's easier to see the rubber piece here on the backside. And you can see how there's chunks missing because it's getting old and the rubber's cracking up. It's not as flexible. This one's still good. It didn't move. The timing mark is where it's supposed to be. It is at top dead center. But I wouldn't put this harmonic balancer back on because the condition of that rubber piece in there, it's just getting old. It's just a matter of time before it lets go and then the ring works its way loose from the center hub. The only thing I can say is if you have another one and you don't want to take it off, maybe take some references through these bolt holes or something, but I think you're still going to have to get all the pulleys off and everything. You might as well just pull the balancer off. Do a comparison with this balancer to a good balancer, and if the line is off, then that's your problem. There's another possibility. Because these engines are 50 plus years old, you might have an engine that 10 guys ahead of you have screwed around with. So sometimes the application of the engine will require these timing marks to be changed. So like on trucks, if you have a 440 and a pickup truck, later, like say late 70s, they would put the water pump housing on a car normally has the lower hose on the driver's side, but on a truck they would move it to the passenger side. When you move it to the passenger side, guess what it blocks? Your timing marks. So what they would do is they'd put the timing marks on this side, they would attach it to the timing cover here, and your line would be over here. So if some Yahoo ahead of you that used to own it changed the harmonic balancer but didn't change the timing chain cover, or vice versa, you have one set of marks here and a set of marks here, and they're way off. So that could be a problem too. I think that's about it for off the top of my head. So hopefully that helps you guys out. You might have a tag like this on your fender well, which tells you your engine size, 440 cubic inches, the RPM, your idle speed, 750, your timing, 5 degrees before top dead center, and then you got your air fuel mixture. Okay, so you go, oh, 5 degrees. That's where my engine wants to run. That's where it wants to run if it's factory. Also, you got to realize that that has to do with emissions and everything like that. That may not be exactly where the engine runs optimally. Usually, the more advanced you can put into an engine, the better it's going to run. But the reason that the factory doesn't go and throw a bunch of advance into it is that it's risky. If you start putting, let's say you start running low octane fuel, maybe the climate you're in makes the engine run a little bit leaner. If you're close to the edge, like let's say Well, let's just say you're all at as advanced as you can be before it's pinging, and then you have another variable come in like climate or fuel, then the engine might start pinging, which will damage your engine. So the factory wants to avoid that, so they're going to put in a little safety factor. So that's why, like in this case, they have 5 degrees before top dead center. Also, something to consider is that if that, like I think this tag came out of a truck later, so it looks like 74, probably lower compression. When you have a lower compression engine, you can run more timing, you can run a little more advanced. So like if this was a 69, I think 69 was saying like 2 degrees before top dead center. So it's like hardly any advance. But anyway, that's all factory emissions, safety factor, all that stuff's factored in. Okay, that's why what you really want to do is you kind of have to adjust your timing based on the fuel you're going to use, the climate you're going to run at, even temperature. And if you're running at the drag strip, the most advanced you want, the most advanced you could squeeze out of the engine, the better, more efficient it's going to run, more power you're going to make. By the way, if you're ever lost on where to start, this is my opinion, but I've always had pretty good luck starting around 8 degrees at idle. Okay, so if you just need to start somewhere, just get something running. Maybe you lost your place on your plug wires or something, and you pulled the distributor out, and you got to reset everything. You don't know where it was. Try 8 degrees. As long as you don't have any pinging when you rev the engine up, you should be okay. But just realize if any of those other variables change, you need to back it down to avoid damaging the engine. Okay, so since we're on the topic, let me explain something to you about motorhome engines and transmissions. So this is another 440 that came out of a motorhome. Had AC, it's got the AC pulley there. Our timing marks are on the correct side, on the passenger side. But if you can imagine this thing being buried in a Winnebago or something, or a van, you know, with the little hood, you can't get in here and you cannot see those timing marks. So on the inside of the van or inside of the motorhome, you have a doghouse that covers part of the engine. You take that off, all your motorhome and van transmissions have a hole right here. Okay, you would pull this plug off, look down the hole, and on the torque converter, you would have scribe lines on the torque converter. So in a way, this is the 4th way you can view timing, but it's only for vans and motorhomes. They didn't bother putting those scribe lines on torque converters for car engines. So you would pull that off, you would use this is your 0 mark. This would be the same mark that's on your timing chain cover. And then the lines on your torque converter would tell you what your timing is, like 10 degrees advanced, 8 degrees, whatever. And it'd be much easier to see from that side than trying to go in from the front where the hood is open and see with all this crap in the way. I need to come up with like a catchphrase slogan. So if you guys got any ideas, let me know. But for right now, we'll just go with the old Dukes of Hazzard. Keep between the ditches. Later, guys.